To demonstrate using AWS Glue for creating pipelines to populate our data warehouse, we are going to use the following scenario. Our company, Globamantics, has stores all around the world. Each store, at the end of the day or at the end of the week, depending on the store, publishes their sales. The data will be stored on AWS S3 storage. Each store will have its own folder and access to the folder, so they can only drop data in their respective folders. The data will be in CSV format, containing the date and the amount of sales for that date. We'll also have a separate CSV file for all the store information inside, like name, size, city, etc. We'll be bringing this information to our Redshift data warehouse as well. And finally, we have features. This will be information about each day for all countries we have stores on. This will contain information on holiday days, fuel price, temperatures, unemployment rates, things the Globamantics Corporation could use for their reports. We'll extract this information, transform it by giving more context, and load it into our data warehouse. We are going to store the data in an S3 bucket, so let's go ahead and create a new bucket. We'll name the bucket Globamantics Stores. You'll find the files I'm uploading here in the exercise files. We have 3 folders containing sales, stores, and features, which contain CSV files for our data. Once the upload is done, we can now navigate to the AWS Glue Management Console. The first thing we need to do is discover our data. We could add definitions manually, or we could use a crawler, which will go through the data and create new definitions for our tables. For this tutorial, we are going to use a crawler to discover our data. After we click the Add button, we need to give the crawler a name. Throughout this tutorial, we are going to use mostly the same name, Globamantics Stores. For the source type, we are going to choose data source. Our data store is going to be the S3 bucket where we stored our files, so we need to select that one from the list. We do not want to add another store since all our data is inside the same bucket, so we'll move on. We can either use an existing role or create a new one. For this tutorial, we are going to create a new one so we can easily delete it later. We also need a database where our tables are going to be stored. This will contain all the discovered tables from our S3 data. We'll use the same name again, Globamantics Stores. We'll also add a prefix for the tables, so every table that is created, it has that prefix, so we know which crawler created it. Once the crawler is created, let's start it. It doesn't take long for the crawler to finish, it also depends on the amount of data, but we don't have that much data. Once the crawler is done, we can find our database in the databases list. Under the table sections, we can see our 3 tables that were created from the crawler. The crawler tries to guess the types, and for the most part, is accurate. If the crawler made mistakes, we can edit the schema manually. For the features table, it seems that the crawler set the date property as string. We'll change that back to date. We also need to change the big ints to double. Once we are done, we hit save. Let's also check the other tables. The sales table also has the date as string, which we need to set back as date. It also has a column named partition 0. This is the folder structure inside the sales folder. Each folder under the sales has for name the store code. The crawler is smart enough to detect folder structure and assume that the folder name is also part of the data. We'll rename the partition 0 column to store code, since that field corresponds to the store code. The stores table is a little different. We see that the crawler didn't set any column names. That's because all the data in the store CSV are strings. The crawler assumed the first row as data, not as columns. But that's not a problem, we can assign column names ourselves, and also tell the table that the first row is column names and not data. To add properties to a table, click on the Edit Table button and add the following table property: skip.header.line.count with a value of 1, which will tell our ETL jobs to skip the first row. Now, let's edit the schema and set our column names. They should match the order of the columns in the CSV file, the names don't have to match, only the order. We are going to join the data in the sales folder with the data in the stores folder, which then will be joined with the features, so we can get the features for the date, country, and city of the sale before we move to Redshift. Let's go ahead and create a new job like we did previously. We'll give the name gsales, choose the same role as we did before, and enable bookmarks for the job as well. For the data source, we are going to choose sales, but it doesn't matter much as we'll edit the code generated by AWS Glue. For the data target, we are going to create the tables, just like we did in the previous job. We don't need to do any mapping in this tab, we'll just save and edit the script. Let's start by removing the boilerplate code generated by Glue. First thing we need to do is add sources. In our case, we have 3 data sources: sales, features, and stores. The code editing UI has some very helpful buttons on the top right corner. We'll choose the source button and select the source we want to add. Once the code is added, we have to remove the placeholders. We'll need to give it a name, so let's name this one sales. The create dynamic frame function also accepts a transformation context. This is a unique ID used for job states. You can give it any value as long as it's unique throughout the script. A good practice it is to give the same name as the variable name. We'll use the name sales for the transformation context as well. We now have added one data source. We'll do the same exact process for the 2 other data sources, features and stores. Once we have all the 3 data sources, we can start joining the data together. First, we need to join sales and stores, so we know which store the sales belong to, and this way we know the date of the sale, the country, and the city of the sale. To join the sources, we click on the Transform button and choose Join Transformation from the list. Just like with data sources, we need to remove the placeholders. We'll name this join Sales Stores to keep it simple. We need to specify the frames that we are joining. Frame 1 will be sales and frame 2 will be stores. Also, we need to specify the keys on which the join will be made. The sales has a field named store code and the stores have a field named code. We'll be joining on these 2 fields. Once we have joined sales and stores, now we have to join the resulting frame with features. We'll go through the same process of adding a join. The difference here is that we are joining on multiple keys. We will be joining on date, country, and city. These 3 fields make a unique representation of the features for the day of the sale, the country, and the city. Once we do the joining, the last step remaining is to select the fields we want. We could just write the join as it is, but that will create redundant and duplicate fields that we don't need. We need to add another transform called select fields, where we provide a frame for the data and what fields we want to select. We'll select only fields for sales and features. We already have the list of stores in the Redshift data warehouse, so we'll leave the store properties out. And now, one final step is to write the data to the source, in our case, Redshift data warehouse. The last line of code was generated by Glue and we didn't remove it. This writes the data into our DB. We need to change the frame and set it to result frame, and maybe rename the variable if you wish to. On the connection options, we can set where the data goes. We can change the name to something else if we wanted to, but in this case, GS Sales is perfect for us. Now, all that is remaining is to save and run the job. Once the job is complete, we can navigate to our Redshift console and refresh the list of tables to make sure that's up to date, and we can see that the table GS Sales has been added. Let's write a simple query to get the sum of sales for each city. Our query was successful and we have results, but not as much as we have data in S3. We are seeing less results here because the features table does not have data for all combinations of date, city, and country. If we populate the features table with more data, then we would see more results here. This is just a demonstration of an ETL job to bring data into our data warehouse. You could also use other data sources from the public domain to test different scenarios with large amounts of data. That's it for this clip. I hope this gave you an understanding on how to use Glue to populate your data warehouse and transform your data with ETL code. We'll look into automating jobs on the next clip.